Today's lesson is on solving equations where there's variables on both sides. So basically, we want to end up having the variables on one side of the equal sign and the plain old numbers or the constant terms, which is the plain old numbers, on the other side. That's kind of your goal. It doesn't really matter if the variables are on the right-hand side and the numbers are on the left-hand side, but we want to get the variables on one side of the equal sign, constants on the other. So there are a lot of different ways that you can do this. So what I like to do is when I see variables on both sides, I like to zero out one set of the variables. So I can either zero out the 4x or I can zero out the 2x. It doesn't really matter which one. So if I'm going to zero out the positive 2x, then I'll need to subtract 2x's from both sides. And remember, whatever you do to one side of the equal sign, you have to do to the other side of the equal sign. And then what do we then have on both sides? So that means we now have 2x's and still a 3 on this side. And isn't a positive 2x and a negative 2x give us 0 x's? So the x's on the right-hand side got zeroed out. So notice on the left-hand side, I'm having my variables. So now I want to undo or zero out the positive 3. So I'm going to undo or zero out 3 positives by subtracting 3 or adding 3 to both sides. So isn't a positive 3 and a negative 3 a 0? And doesn't that leave me just 2 x's on the left-hand side? And don't I have negative 14 on the right-hand side? So do you notice that I have the variables on the left-hand side and the plain old numbers on the right-hand side? Remember, that was my goal, to get the variables on one side and the constants on the other. So I've met my goal. Now I need to figure out what 1x is. So I'm going to divide both sides by 2. And that will tell me that 1x is equal to negative 7. So our solution is that x is negative 7. I'm going to do the same problem over here, but I just wanted to show you that there are multiple ways of doing it. Maybe somebody else said they wanted to zero out the constant first. So maybe they wanted to subtract 3 first. And as long as they do it to the other side, that is possible as well. Notice the positive 3 and negative 3 zeros out. Just make sure you're putting the equal sign and you're following the math. Isn't 11 negatives and 3 negatives 14 negatives? So notice I have all of the constants, the plain old numbers, on the right-hand side. So wouldn't it make sense to then subtract 2x from both sides? And doesn't that leave me 2x equals negative 14, which is what I had earlier. Divide both sides by 2, and you get the same answer as x equals negative 7. So there are multiple different ways of solving an equation with variables on both sides. However, this is the way that I choose to do it. I like to zero out one of the x's first instead of zeroing out the constants. So let's look at another problem. Here you have a problem that has a lot of terms. Some kids like to put a little line down the equal sign so they can see the left-hand side from the right-hand side. That's up to you if you like to do that or not. Do you see on the left-hand side that there's 4 terms on the left-hand side? And do you agree that these 2 terms are like each other because they're just plain old numbers? And the x's are considered like terms because they have x's in them. So we're going to combine like terms first. It's always smart to combine like terms first if there are any. So 1x and 3x, doesn't that make 4 x's? And a negative 5 and a positive 2, doesn't that make a negative 3? So we're going to say minus 3. On the right-hand side, these are not like terms. Those are not like terms because the first term has an x and the other term is just a constant. So those are not like each other. So we're just going to recopy those. Now I'm going to try and get my variables on both sides. Again, I personally like to undo zero out a set of variables. It doesn't matter whether you zero out the 4x or whether you zero out the negative 3x. It doesn't matter. So I'm going to zero out negative 3x's by adding 3x's. And whatever I do to one side, I have to do to the other. Remember that a positive 3x and a negative 3x gives you 0 x's. So that leaves you just a 4. And then 4x and 3x is 7 x's, and then we still have the minus 3. So notice how that got rid of the x's on the right-hand side, and now I have all of my x's on the left. So obviously now I need to undo the constant. And if I have 3 negatives or I'm subtracting 3, shouldn't I add 3 to both sides? Because isn't a -3 and a +3 zero out? And leave me just the x's on one side. Then, now that I've got all the variables on one side and the constants on the other, I can divide both sides by 7 because that will give me x equals 1. So the solution is x equals 1. Following the steps and combining like terms is very important because it can save time. Make sure you're showing work. Whatever you do to one side, you have to do to the other. And make sure that if you're adding x's, you remember to put the x in with your term. Number 3, once again, if you have like terms, you should combine like terms. Notice on the left-hand side, I have 3 terms, and these 2 terms have x's in them, so those are like each other, so I can combine them. So what is 6 negative x's and a -4 x's? Isn't that give us -10 x's and then the -8? You have to know how to add integers in order to combine like terms. So practice your flashcards of adding integers if you don't know how to combine like terms very well. Now here's an interesting question. If I zero out the -8x's by adding 8x's, make sure you follow the math. Your equal sign has to line up. That gives me -2x's and a -8 and nothing on the other side. That was not a smart move in this particular problem to zero out the right-hand side x's, because that left me with no terms on the right-hand side. But if I do that and I follow through, because remember our goal is to get the variables on one side of the equals and the constant on the other, and I'm not there yet. So I would have to add 8 to both sides to eventually get my variables on one side and my constant on the other. And then I could divide both sides by -2. And that would give me x equals -4. So if we go back, and as long as you follow the math and do the correct math and don't move your equal sign, you'll eventually get to the right answer. But I think we'd agree that maybe zeroing out the right-hand side x's was probably not a smart move in this problem, because if you look, don't you see that all the x's are already alone on the right-hand side? So wouldn't it have been smarter to zero out these x's? So you have to kind of think about what you're trying to accomplish. That gets rid of all the variables on this side and leaves just the plain old number or the constant term. And by doing that, I have just the x's on the other side. So that was a smarter move for this particular problem. And then I can divide both sides by 2. And I get -4 equals x, which is the same answer I got before, but a little bit less work. So making good choices. I don't want to end up with no terms on the other side if I can keep it from happening. And then the last problem. Notice in this problem we have to distribute first. So remember that means a -1 is being multiplied to both of those, and then at the same time we can multiply -4 times both of those. You need to watch your sign errors, lots and lots of sign errors. So rewrite the 2, and then a -1 times x is -1x. A -1, so watch your signs, a -1 times a +5 is a -5. And then a -4 times a +2x is a -8x. And a -4 times a -3 is a +12. And then we recopy the 2x. So first you got to distribute, which means you got to multiply. You must watch your sign errors. And then doesn't it make sense to combine like terms? Aren't these 2 terms like each other? So can't I say I have a -3 and -1x on the left-hand side? Aren't these 2 terms like each other because they both have x's? So can't I say I have -6x's and a 12 on the right-hand side? Right? Because 8 negatives plus 2 positives gives me -6x's. Now I'm going to go ahead, and since I have variables on both sides, I'm going to zero out these x's by adding 6 x's to both sides. Notice how I line it underneath the term that it's like. Isn't a negative 6x and a positive 6x, doesn't that give me 0 x's and leave me just the 12? And then don't I have a negative 3 and a positive 5x on the left-hand side? Now I can zero out the negative 3 by adding 3 to both sides, because a negative 3 and a positive 3 is 0. And that leaves me just 5 x's on the left-hand side. And then 12 plus 3 is 15. Now that I have all the variables on one side of the equals and all the constants on the other side, which was my goal, now I can divide both sides by 5 to get x equals 3. So that's how you do variables on both sides. You could go back and copy down a couple problems that I did and practice them and then rewatch the video. I hope this helped.